Hi, my name is Todd Barrett. I teach the IT&C 441 Embedded Systems class in the College of Engineering and Technology. With registration going on, you have a number of options to choose from, particularly for technical elective classes. If you aren't in the IT or cybersecurity majors, you may want to check with your specific program to see if this class counts as an elective toward your degree. Or you can always take it just for fun because it is one of the best classes at the university, but I'm a little biased. I've received a few questions about the class, so I put together this video to give you a preview of what to expect. Embedded systems are all around us. More and more devices are becoming smart. As we incorporate smart TVs, smart doorbells, smart thermostats, and yes, even smart vacuums and crock pots, the world around us is evolving into an ecosystem of connected devices. While much of it appears as magic, the reality is that this world is built on billions of microcontrollers. Very small, low-power computers built to do a single purpose. In this class, we learn the fundamentals of embedded devices, from high-level system design to each individual component of that system. We start with the user experience in mind, and then we design a system that integrates various components, some that we design and build, and some that exist already as cloud services, software packages, or even physical devices. We will also consider the security implications and risks of the systems and components we are designing. So what is the anticipated workload for this class? Well, the bulk of the coursework is centered on 6 labs throughout the semester. You will be given about 2 weeks to complete each lab and lab report. In general, students report that they spend anywhere from 6 to 8 hours on each lab, so about 3 or 4 hours outside of class on average each week. Additionally, each student will prepare one 20-minute presentation on an IoT or security topic of their choice, as long as it pertains to embedded systems or Internet of Things devices. Students will present this during class throughout the semester. As part of helping each other learn and grow, each student will be required to evaluate their classmates' presentations and to provide feedback to help them improve. I know, we all hate group work and evaluations, but don't worry, it's anonymous, and I promise it'll help you do better. It does also require you to be present in class each week. Lastly, in lieu of a final exam, each student will do a final project instead. For this, you'll apply what you've learned in the class and build a device of your own creation that fits in the ecosystem of other devices that you build for your labs. For midterms, you'll do a project proposal presentation and a report. Then you'll have the rest of the semester to work on your project. For the final, you'll present your completed project and turn in a written report. These projects are always awesome. Students have made smart fish tank feeders, smart alarm clocks, custom lighting systems, UPS and Amazon package drop boxes. The possibilities are endless. In fact, here's just one example of the type of project you could do. This was my son's Halloween costume last year, built using the technologies and components that we'll be talking about in this class.
This is my favorite costume. The gun will shoot and then you stick this in.
So red means it's out of bullets.
Yeah. And then you'll stick this in, and it'll turn green.
And show me your arm. And your arm just went to 8 bullets. Okay, what happens?
Then you can shoot.
What happens if you touch the screen on your arm?
And if I touch that, it'll turn the lights on.
And how do you reload?
You pull this out and stick it back in.
And now you're
That's
back up
the
to 8.
bullets.
Nice. So there it is, no tests, no endless sets of math problems, just some hands-on labs, reports, and presentations, and a whole lot of really cool projects. Let's talk about the labs for just a minute. What do the labs involve? Let me show you exactly what we'll be building for a couple of them. Much of what we do will be based on the Arduino platform. This is an open source hardware and software platform that's very popular. Please don't worry if you haven't worked with it before. This class is intended to be an introduction to the platform for you. In one of the early labs, you'll get familiar with this platform by building a web-controlled LED stoplight from scratch. Sounds easy, right? Let me show you what our final device does. We'll use a microcontroller that can connect to Wi-Fi. On the device, we'll program a web server that serves up a very basic web page. Don't worry, you don't have to copy my design for the page. Yours can be way cooler. It's okay. That sounds easy, right? We'll also learn how to control basic circuits with this same microcontroller so that the web page will actually control the LEDs on the device. This is a fun example of a new device we build. But it's only part of a bigger ecosystem. Each additional lab will augment our smart home with additional integrations, like this distance sensor. This device is great for measuring how far away something is. This is a helpful tool in building smart systems that need to interact with other devices in the physical world. But it is the integration of these two devices together that start to open up new possibilities. We'll learn about communications protocols, web-based and others, to help devices talk together to make everything a little bit smarter. Look at this. In our case, our distance sensor and stoplight work together really well to automate the kids' game of red light, green light. As the object gets closer and closer to the device, the stoplight adjusts accordingly. This is perfect for encouraging social distancing with those around you. I hope you're excited at the things you'll learn during this class. However, I do understand that it may seem overwhelming. Let's talk about the prerequisites that will help you be the most successful in this class. You don't need to have experience building complex circuits. This class is intended to be an introduction to the topic. You will, however, need some basic programming skills. You should have completed an introductory programming class before taking this one, something like CS 142 or a major specific class like IT&C 210. There isn't a hard requirement for which class. I'm just counting on you knowing your way around HTML and preferably something like JavaScript or Python, maybe some CSS, or a different language like Java or PHP. You don't have to be a hardcore web developer to be successful in this class. It's also helpful if you have some basic circuit knowledge. We'll review what you need to be able to complete each project, so it's okay if you don't. It will just help with some of the troubleshooting if you get into some challenges along the way. For the class, we've tried to make it as straightforward as possible. In lieu of an expensive textbook, we only require you to have a working Raspberry Pi for the class. You don't have to buy the latest and greatest either. An older Pi should work just fine for what we'll be doing with it. If you have one that you're already using for something else, you may want to get a fresh new SD card so you can switch between projects more easily. The additional materials, the lab kits, class demo kits, and other things will be provided for you. You don't even have to wait in line at the bookstore or wait for a bunch of parts to be delivered from China. We'll take care of all that for you. So I think that's about it. I hope this video helped answer some questions you might have. If there's anything I missed, please don't hesitate to reach out to me. My email is todd_barrett@byu.edu. I look forward to seeing you in class. Thanks.